with SimActive, and we've got a webinar today for you, and it is Photogrammetric workflows to improve outputs for infrastructure projects. So really what we're talking about is how to clean up our surfaces and make everything look good when the customer is looking at the data set. So you've got myself. I am the Senior Workflow Specialist for SimActive, and I've got my guest speaker, Thomas Barucchi, the Photogrammetry Specialist here at SimActive. And I really wanted him on board here because he spends a lot of time working with data sets and looking for ways to make improvements in those data sets and the results. So Thomas, go ahead and introduce yourself.
Hey, hello here, Eric. Hello, everyone. Very glad to be here with you today. So yeah, I'm Thomas Barucchi, based in France for our European branch at SimActive. And as you just said, Eric, I work as a photogrammetry specialist.
Fascinating. I love working with people from the other side of the earth, so that's great. And in here, if you could see in my camera, I have moved rooms. So folks that have followed along on these webinars, I moved from the front of the house to the back of the house. We've got some construction going on next door, try to minimize the noise. And yes, I have a Peloton, I get on it all the time. But let's get on with the topics ahead of us. What we're going to do is we're going to discuss the DEM editing tools and some of the processes. These will help you create better surfaces using these tools, and specifically for infrastructure projects such as buildings, bridge overpasses, elevated roadways, those kind of things. And then we also have some inspection tools built into Correlator 3D, so you can take a look at those. And then, which options are right when you're building your ortho photos and your mosaics for your final delivery. So with that, we'll put away the PowerPoint presentation and get right to business. I'm going to turn the screen over to Thomas, and let me do that. I'll make you the presenter.
Thank you, sir.
There you go.
All right. So can you see my screen, Eric?
Yes. I'm going to go ahead and go.
Awesome. All right, so I'll just quickly go over the different tools we have and the different techniques you can use to fix some issues you may have when you work with, as you said, elevated structures, bridges, overpasses, things like that. This is a project in British Columbia, Canada. And the camera we have here is a pretty large sensor. It's a DMC sensor. So this is something like 375 megapixels. But the techniques and the tools we're going to present today, it works with any type of project, any sensor you have, like UAV or any data you want to process. You can use the same techniques. So maybe we can start by presenting the different DEM editing tools we have. So I'm not going to go through the presentation of the GUI and then the presentation of a typical workflow, because this is something we have covered quite a few times in our previous webinars. So feel free to go on our website and check. You have plenty of tutorials and videos in case you want to learn a bit more about the software. So when you generate a DSM, which is what I have on my screen here, you can enter the DEM editing module by clicking this guy here, this big button. Well, actually in Correlator 3D, each time you see an icon with a pen, it's an editing module. So if you want to enter the editing module, you can click here, or you can either go on the standard top bar here, module, and then go into the DEM editing. When you enter a module in Correlator 3D, you will have a bar on the right side of the screen with the different tools available. So this first button here is our polygonal region selection. So if you just draw a quick polygon in an area, this is how you can create a polygon and then use this polygon to do different things. You can save it to save the polygon, and then you can also save it to a file. If you click here on the third button, you will see in the vector, in the layer tree, under in the vector category, you will have your new selection, which you can save and save as a shape file, for instance. The second button you have here is the rectangular region selection. So this is like a nice one to use when you want to crop, do like a rectangular crop, for instance, or if you want to select like any rectangular selection you may want to do, you can use this guy. Quite useful. The third one here is edit a selection in a file. So if you draw a polygon somewhere and then you save this guy in the layer tree, I'm going to call this I don't know, test. You can add more polygon to this file by clicking here. If you draw another polygon somewhere else and save it, this will save the second polygon in the same test shape file. So this is useful when you want to like draw multiple polygons, for instance, around multiple buildings, in case you want to edit them or crop them, or anyway. And you also have access to the rectangular selection when you add more polygons too. This guy here is the touch-up small region tool. So if you have like a, I don't know, maybe small noise, let me zoom in an area and show you how this one works. I don't know, maybe the trees we have here, instead of drawing small polygons around those trees, let me remove this this file here. Instead of drawing small polygons around the trees, you can use the small touch-up button, and then you can simply click over these trees, and then the software will just like remove them from the DSM. This is a nice one when you have like, I don't know, maybe over an open, like a water body. You know that in photogrammetry, when you generate a DSM over a lake, for instance, it generally creates spikes. So if you have a few of these spikes that you want to quickly clean up, you can use this the touch-up small region option. Then we have the crop a selection. So if you draw a polygon, around the DSM, which I'm going to do now. And I have a bit of a lag with my internet connection. Sorry about that. So if I draw, I don't know, a small polygon here, and then I want to crop my DSM to this region, I can click here and crop to a selection, and then the DSM will be cropped. Of course, we keep a history of all the modification you apply to the DSM or any DEM, DSM, DTM. So if you want to step back, you can simply click on the previous step on the DEM history window. The next one here is delete a selection. So if you want to delete an area from the DSM, instead of cropping, you click on the delete a selection. This will like create a hole here. And again, you can step back by clicking on the previous step here in the history, DEM history. This next one here is set elevation of a selection. This is one of the tool I use. This is the tool I use most of the time for to flatten the noise I have on water bodies. So I don't have any lakes, I think, in this area, but let me show you how this works. Let's say this park at the center here is a lake. Let's pretend. So if you draw a polygon around the lake, I'm going to do something very quick here. And then let's say you have lots of noise in this area and you want to flatten the area. Maybe you can check the average elevation at the boundaries of the lake. So in my case, I'm looking at the bottom right side of the screen here, where I can see the elevation of my mouse. So it says here 67.44 meters. So I can flatten this to maybe 66 meters. You click on the set elevation. You have two types of operation. You can set to an actual elevation. So 68, did I say that? Yeah. Or you can apply an offset elevation. So this will use the actual elevation of the DSM and then apply an offset. So when you do this, you apply this set elevation. You flatten the area to a given elevation. It's quite useful when you want to remove the spikes you can see on a lake, for instance, or if you have I don't know, the roof of a building that has like a bit of a noise, a topographical noise. You can draw a polygon around the roof and then flatten the top of the roof by using this option. And then this guy here is to filter a selection. So you can, when you do a selection with a polygon, you can use a mean filter or a median filter. I'm not going to go too much in details about these filters because it's quite complex. But if you go into the user manual, you will find all the details. And I don't remember where this on which page this thing is. DEM editing. So if you go on section 7.4, you will find all the details about like the difference from the mean and the median filter, the size here you can apply, and then how this thing work. The next one here is the delete and fill a selection. This is another one I use quite often when I'm doing some DEM editing. So if you draw a polygon around a tree again, instead of using the small region touch-up tool, what you can do is use the delete and fill. So again, I have a bit of lag. If I draw a polygon around this big tree here, whoop.
Yeah, already you've mentioned two things that I really like. It is that small filter, and the fact that you have that DEM history window open. That's something people need to remember when they start doing a lot of editing.
Yeah, exactly. And then there's no any limitation here. Even if you do like, I don't know, 300 steps of DEM editing, we save them all in the DEM history. So that's a nice thing. And then when you do a mouse over actually on the DEM history, you will see that the polygon here will have a number 3 on top of it. So if you do like, I don't know, 100, if you draw 100 of polygons to do like some intense editing, you will see which modification is related to which polygon on the project. So the delete and fill here, if you look, what the software does is it will check on the boundary of the polygon the average elevation of the vertexes, and then it will just like simply interpolate and delete and fill up the area using the surrounding elevations. So you can remove trees. This is quite useful when this is one of the tool I use the most often when I'm doing a DEM editing. It's a very useful one. The other one, the next one here is the same as the delete and fill, except that this one will preserve the topology. So if you're doing a delete and fill on a steep slope, for instance, to avoid having like the step effect, creating a break, you can use the delete and fill while preserving the topology, and this will like smooth out the delete and fill process.
So that's handy on things, and that's handy on things like levees and berms and the side of bridge abutments, heading up to the side of a bridge abutments, those kind of things.
Yes, exactly. And the next one we have here is extract a DTM for a selection. So if you draw a polygon around this building, for instance, and then you want to extract a DTM, like you manually want to extract a DTM from this DSM, you can do this locally here, and then this will like just simply calculate remove the building from the selection and then just leave the bare ground. So it's kind of like another option. Sometimes when you have a DSM that is very, it's actually like most of the DSM is the bare ground. So you don't really have to like run a full DTM extraction. what you can do is like maybe draw a few polygons around, like maybe if you have a few cars or a few houses, but all the rest of the project is just bare ground, then you can just like generate the DTM locally in these areas by using this extract DTM for a selection. And this last one we have here, and my screen is at a lower resolution, so we don't see all the tools, but if I click on the small arrow here, I have one last tool here, which is paste a DEM from a file. And that's one of the tools we're going to like talk for the next few minutes, because it's the tool you want to use when you have to copy paste some features from a DSM to a DTM, for instance. And why would you do that? Well, I'm going to show you here. We have a nice bridge here crossing the highway. So when you do your ortho rectification over the DTM, so over a flat surface where all the bridges are gone, all the houses are gone, what you may observe is a misalignment. So let me show you. If we generate, if we ortho rectify over the DTM in this project, what you will see is something like this. Is this my, yeah? And if we load we have like the chance to have like some vector files for this project. So we have all the roads. This is a shapefile, like a polyline shapefile. And as you can see, if we zoom in here, you see that there is a shift. There is a misalignment between the vector file, which is where the road is supposed to be, and the actual highway. I mean the actual bridge. So this is happening when you ortho rectify. Well, it's actually pretty easy to understand. You ortho rectify the image over a flat surface, the bare ground, where on the image you see an elevated bridge. Like this bridge is supposed to be elevated compared to the ground. So the distortion, it's kind of like trying to ortho rectify an elevated structure over a flat surface. So in most of the cases, you will see like this kind of misalignment. So how can you fix this when this happens? Well, you have two options. First, you can do a true ortho rectification for the whole project. So instead of like ortho rectifying over the DTM, you will load the DSM, and then when you will click on the ortho rectify image, you will have the option to click on the DSM-based ortho rectification, which will generate a true ortho, and all the ortho rectification will be done on over the DSM, so you won't see this effect anymore. But sometimes, as you may know, Eric, when you do a true ortho, it creates some artifacts on the sides of the building roofs, for instance, or over like elevated structures. So sometimes you may want to like still do a standard DTM ortho rectification, but you still want to like fix the offset you observe, such as the one we see over the bridge here.
Yeah,
so the best way to
let me just add to that. I mean, the two primary products are a DSM and a DTM. The DSM has everything in it. Trees, buildings, all of that information. And that's good, but it also, like you're saying, Thomas, it can leave artifacts. One thing that really bugs me about DSM sometimes is when you're doing, saying something like a utility corridor, and in the center of that corridor, it's mowed flat grass, but on both sides it's vegetation and trees, and they're usually high trees. Well, if you go to ortho rectify that and mosaic in DSM mode, your trees in that mosaic will be spread out and going in every direction, and it visually it's not that pleasing. So there are times when both are used for a better purpose. And now what Thomas is going through here is just because we use one doesn't mean we can't take the other and merge it in, or pieces of the other and merge it in to get to a better result.
Yeah, exactly. So this is something I use quite often when I'm I'm dealing with these offsets or misalignment. So what I like to do is to extract the feature where I observe the issue from the DSM and paste it in the DTM. So you have two options to do this. You can either manually draw a polygon. So let me remove this vector file. You can either manually draw a polygon around the bridge. So you will simply enter the DM editing module here, and then you will like draw your polygon around the bridge. So I'm doing things very rapidly here, but you see like this could take like quite some time, but it will really help to fix the issue. The other option you have is if you have access to some vector files. So this is an option we have in the software. If you go in the layer tree under vector and click to the on the plus sign next to features, you can import and bring in some vector files. So these vector files can be used to do this crop and copy paste actions. So here, what I did is I selected the polygons around the bridges here, and then I saved only the two polygons of the two bridges here. So I don't know if it's kind of hard to see here. Yeah, you see the two polygons here. So once you have the two polygons, what you can do is like go back into the DSM editing module, and then you can crop if you select your road poly file here, you can crop the DSM and then only keep the bridges. So if we look at my bridge here, as you can see, we only now have the bridges, and this is what I am going to paste in my DTM. So this is what I will call now a hybrid DTM. So it's an actual DTM with a few features coming from the DSM. So it's not a full DTM like a digital terrain model. It's a hybrid, let's say a hybrid DTM. So if you paste these bridges, and again, if you enter in the DM editing tool, this guy is located here. You click on the paste a DM from a file, and then you will paste bridges. So if you do this, what you will obtain is my DTM hybrid here. So as you can see, and then I'm going to talk about the buildings here. This is my next example. But in my DTM, in my hybrid DTM, you can now see that I have my bridges. And then if you now ortho-rectify using these bridges that have been integrated in the DTM, you will see that we won't see the misalignment anymore. So let me load my other mosaic folder here and then load the mosaic. So if we now zoom in the mosaic, we'll see that everything is now well aligned and I don't have this offset anymore. So this is one of the techniques I use when I work with elevated highways, overpasses, bridges, things like that. It's a nice, quick and easy way to, especially if you have access to some vector files. It's not always the case, so you may have to like manually draw your polygons and then do your crop and then paste in the DTM. The other type of issues you may see when you ortho-rectify over a DTM is, let me load the mosaic back here. So if we look at the building here at the center, let me zoom in a bit. You will see that we see the actual wall of the building. There's some paintings like planets, looks like, on the side of the building. Well, this is simply because I have ortho-rectified over the DTM, so over a flat surface here in this region. And if you want to have like a very nice sharp edge of the roof without seeing the facade here, the wall on the side of the building, it's actually the same technique. You will extract the building from the DSM. So if you go back to the DSM, you will see that we have the bridge. You can draw a polygon around the building, sorry. You can draw the polygon and then crop the DSM to this building and then paste it in the DTM, which is what I have here. It's the reason I have my my building here on my hybrid DTM. When you do this, you have to know that you don't have to do it for every single buildings. If you want to do a bit of a true orth rectification in one particular area of the project, you don't have to like draw polygons for each building at the same time. What you can do is extract all the buildings together by using this technique I am going to show. If you enter in the DSM editing tool here,
give it a second to load. There you go.
Yeah, to refresh. Let's zoom back in this this area. So we have a tool to it's called snap to an elevation, snap to a given elevation. So if you draw a polygon in a region, in a given region, and again each time I do a zoom, I have my internet lag, which takes a few seconds. If I draw a polygon in this region, so let me quickly draw. Feature has changed. Do you want to save it? No. So I'm going to draw a polygon around like all these buildings here. So I draw my polygon here, and then I put my mouse on over the ground here just to check what's the average elevation, and I see 4.4 something meters, 4.6 meters. So what I am going to do is I'm going to click on this button here, snap selection based on an elevation, and I'm going to ask the software, can you snap to any features with an elevation above, 8 meters is okay, I think. And if you click on process, you will see that the software just refined the selection to all the features that are 8 meters above the ground or higher. So if I crop now my DSM to this selection, you will see that I have a bit of a cleanup to do, which I can quickly do live here. So if you want to remove the trees here, for instance, you can quickly draw a line and then remove the trees.
Yeah.
And then you can click here on the delete selection. So you can do this for like to do a bit of a cleanup of your buildings. And in a matter of like a minute or two, you will be able to like get all the buildings instead of like drawing each single polygon manually. So when you do this, you can then paste this, well, you can save it. You can go into File, DEM, Save As, and you can save these cropped buildings into a new file, which is the file I have here. Do I have my buildings? Yes. Oh no, this is a single one I have here, but it's the same. So if you save this and paste it in your DTM, you will now have all your buildings in your hybrid DTM. And if you now orth rectify with these buildings on the DTM, you will be able to get a nice. Let me load back the other mosaic I have created. You will see that we don't see the wall of the building anymore. So the building is very well orth rectified. So the issue has been fixed. So this is an option I use when, and to be honest, like most of the time you don't have to do a true ortho over the whole area. What I generally do is like I try to locate to find all the very high buildings. You know, sometimes you even have like skyscrapers or very tall structures within the project. And so these are the type of elements I will crop and copy paste from my DSM into my DTM. But the rest, for like the rest of the project, all the small houses, I just like leave the DTM as is, and I have like very nice results.
I was gonna just gonna throw one thing in there. When you create after you've created the DSM and you decide that you want a DTM, one of the options is to output all of the features that are being removed into another file, which is very similar to what you just did. You could open that file of removed features, and you could go in and edit that as well and say, you know, like you say, put a boundary around the buildings in the residential or the urban area, delete everything else, and then bring that back into the DTM, and you've kind of done it it's the same steps, you're just doing it a different way.
Exactly. And it's a very efficient way to, and it's actually like faster compared to like trying to fix a true ortho over the whole area.
Right.
It's way faster to like localize. I mean, to try to find the areas where you have like this type of offsets or artifacts over the buildings, and then you kind of like work in small regions to fix the issues, and then you get the expected results. But the other thing I like to use is so as I mentioned, the snap to elevation. So if you work on a like kind of flat region, not like in a mountain region, so let's say in this urban area, and you have a few like usually the center downtown or the financial suburb where you have like all the very tall buildings, what you can do is like quickly draw, make a rectangular selection in this area, and then snap to, I don't know, all the buildings that are above 200 meters or higher. And then you can quickly extract those buildings. It's done in a matter of minutes. And then you do a bit of a cleanup once you have extracted those buildings to like get nice and sharp edges. And then you paste them in the DTM, and you have fixed your ortho rectification issues. There is another tool. I mean, we have like a few tools here. The DEM inspection. This guy is when you want to inspect your DEM based using ground control points. So if you have ground control points for your region, and you want to check like how my DSM is compared to the GCPs. So you will select the DSM here, and then you will select your GCP file. And this will like show you that we have an RMS error of 33 centimeters for this project. You see like a few different values, and we're just like using 3 GCPs here. So, but if you have, if you have, I don't know, 10, 20, 50 GCPs, the algorithm will do this check over all the GCPs and show you like how accurate the DSM is vertically compared to the GCPs. The other one we have is the change detection. That's a good one when you want to compare different surfaces. So an example I always give is the landslide. Let's say you fly a mission in January, and then during the summer there's a big landslide happening on a mountain, and then you fly on September and you want to calculate the amount of material that has been displaced by the landslide. Well, you can bring in the 2 DSMs and then use the change detection. And then you use your the January DSM as a reference DEM, and then the September DSM as a comparison DEM, and this will create a new surface where you will only have the topographical difference from the 2 different DSMs, which is the amount of material that has been displaced or removed. And then you can also use the volume calculation in case you want to do a bit more of an analysis. The other example I always mention is when you cut trees. So let's say you fly over a forest and then some trees have been cut. You want to calculate the amount of trees or the amount of material that has been cut. Then you can compare the two DSMs before and after the trees have been chopped, and then you do your change detection. You use your change detection tool. We also have the DEM contour extraction. So this is like a very standard contour extraction. You select the interval from your DSM, and then you can also apply an offset to your contours, and you can add an attribute, an elevation attribute, where you can customize the name depending on your needs.
One thing we talked about, you and I talked about just the other day, was when you're creating your DSM, if, for example, and it's in an area where you have lakes or something like that, and you want to maintain the elevations of those lakes, you can bring those in as a shapefile with elevation data attributes to them, and then when you create the DSM, it will acknowledge those areas and leave them as, you know, flat surfaces. Is it correct?
Yes, exactly. So this is what we call the 3D constraint.
Yep.
So if you go into the DSM or DTM generation module, there is a small button here which says constraint. So it says if I click on this guy, the selected constraint file needs to be added from the project tree. So what we need here is to bring in a shapefile with elevation values. So either it could be like a points, polygons, or polylines. As long as these vector files have elevation values, you will be able to use these vector files as an elevation constraint. So as you said, the lake example is a very good one. If you have the boundaries of a lake in a vector format, and you can set, give an elevation attribute to this vector file, you will then be able to import, and again, this is located in the vector category here under features. If you bring in this lake boundary file with an elevation value, you will be able to use this as an elevation constraint, and then the software will force the DTM or the DSM, doesn't matter, to use this elevation constraint within the lake boundary. So it's a nice, like when you have access to some vector files of either lakes or roads. I've also seen, like on highways, depending on the texture, but if the texture is very reflective, let's say, you may see some noise over the highways. Well, here we have as I mentioned, we have like all the roads polygons, but they don't have any elevation attributes. But if I can like give some elevation attributes to these roads, then I could very easily use these roads as a 3D constraint to simply remove all the noise that I could observe on the roads.
Yeah.
Or maybe the cars.
Yeah.
Like sometimes you see spikes just because of the cars you have on the highways. I think we do see a few cars here in my DSM. But anyway, it just shows that that's another good option, and it's nice that you mentioned this, because I forgot to talk about it. The 3D constraint is quite powerful when you want to remove noise or to avoid doing manual editing.
Yeah, I know.
The surface.
I know, you know, in some of the previous companies I've worked with, we've done shoreline mapping along the ocean, for example, and we've been able to use the 3D constraint there to hold the elevation or to hold the quality of the mosaics in processing. And the other place I've seen it a lot is we might be doing, you know, down in the Keys or something like that, where we're bouncing from island to island and we've got, you know, channels going in between. We can use that 3D constraint to hold things together as we go across the water. So I find it a really powerful tool.
Yeah, and it saves a lot of time, because you know, when you have to, like, when you work with very large projects, thousands of images, when it goes to like doing some editing over the DSM, this can be like time consuming. So having all these tools within the software makes our life easier, and then saves a lot of time. So this is something we like to use.
Yeah, and again in the mosaic creation window up there, we've got I can't remember, is it the mosaic creation or is it the ortho creation where we have the true ortho? It's the ortho creation.
Yeah, the ortho creation. Yeah.
Mm-hmm. So it's something to consider, because depending on what your output is and depending on what surface you're using, you may or may not want to use that DSM-based true ortho. And then again, there's a constraint file there that you could use as well.
Yes, exactly. Yeah, you always have to ask yourself when you before you start ortho rectifying, do I need to do a true ortho? Is this something required by the customer or by the project itself? Because I would say that when it's not required, I always go with the standard DTM-based ortho rectification, and then I check my mosaic. I check if I have any like misalignments or any issues, and then I fix it from there instead of, I mean, if it's not required, because visually the DTM ortho is always like a better, like most of the time it's better looking visually. So if you want to get like the best visually looking mosaic, you will probably like go with the DTM based ortho. But the true ortho rectification works very well at the same time, but it's just like a question you have to ask before you start ortho rectifying.
Yeah, it's like when you build your DSM. Do you want it as optimal or do you want it as maximal? They both have their benefits. Maximal is going to provide you a more intense data set. It'll also take 4 to 5 times longer to process. And it'll probably bring up more artifacts for you to clean up. So, which is the better based on what you're trying to do. And then in the ortho creation tool that we have, you do have the ability to crop the images so that you're working with more of the center of the images based on how much overlap you have, things like that.
Yeah, this is something to like explain this. I always use the fisheye example. So let's say you fly, like, who knows why, but like, because in photogrammetry, it's really not suggested to use a distorted lens, distorted sensors such as the fisheye distortion effect, because you will have lots of distortion like when you go on the side of the image, and this will make it very complex for the software to deal with this distortion and to ortho rectify properly the image. So this is the reason we have added this option here to crop a certain amount, a percentage of the side of the image. So when you have like the fisheye image, you can crop, let's say, 10% on the side of the image to keep the most undistorted region of the image, and you will like greatly improve the results by using this option here. Of course, it requires to get like a nice front and side overlap, because if you have like a very low overlap, you will probably like you will miss information to do the mosaicing.
Yeah, and it's not. It's not as easy to see when you're working with large format cameras covering large areas, but especially for the folks in the drone world, you're so low to the ground that you certainly have image distortion. And
always.
flying your projects in, saying, if you're doing something in an urban environment where you've got those large buildings, get your overlap tight, maybe even do a gridded collect, so that you can use more towards the center of the images instead of the whole image.
Yeah, and it really like greatly improves the results. Like if you compare, if you have like a data set with a very distorted image, like the fisheye lens ones, you can do the test. Like you can try to use the whole image, or you can try to crop the side of the, I don't know, 10-15% of the side of the image. The quality of the mosaic is really different. So this is a nice one to use when you have these and also when you fly at a low elevation, as you said.
Mm-hmm.
Maybe one last one we can talk about is one that I use really often. It's when you create a DSM, there is an algorithm, and this is quite recent. I think we developed this last year. We can use the DSM to ask the software. So when it comes to like mosaicing the orthos together, so to stitch the orthos together, there is an option here. If you load the DSM in the layer tree first, and then you go into the mosaicing module, there is an option here that says use the loaded DEM for simline obstacle avoidance. And what this does is the algorithm will go over the DSM and try to recognize any elevated structure, so buildings, cars, trees, and it will try when it's possible. So of course, with like a very big camera that we have here, it works really well. But even with a UAV, the software will try to put the sim lines on flat areas and not to cross any buildings. And this also saves quite a lot of time of editing when it comes to like doing the sim line editing in the mosaic when you're doing the fine tuning of the mosaic. So the algorithm is smart enough to like try to put, to put all the sim lines on flat areas. So this is one I always use this guy when I'm dealing with big projects, and I know that I will have like a few sim lines crossing buildings here and there. So I check this box here, and it saves me time. So.
And the other one in there that I always remember is the nadir optimization.
Yes. So this is kind of like we were talking about cropping the side of the image when you're using like, I don't know, maybe smaller sensors, UAV sensors. By clicking here, the nadir optimization, the software will maximize the most nadir region of the image during the processing, during the mosaic creation, to get rid, when it's possible, when the overlap is high enough, and will neglect a bit more the side of the image to use more the nadir region of the image. So this will also improve the quality of the mosaic, and it will give you better results.
So it's not forcing a crop of the images, but it's going to start working from the inside out and try to use as much as possible. Yeah.
Exactly. So when it's possible, it will use like the central region of the image, and then in some areas where it needs to use the side of the image, it will like. But as you said, it starts from the center, and then it slowly like goes towards the sides.
Yep, very good. Really, the only other thing I thought you might show people is, when we went down there and we did the slice of the buildings by elevation. So when we crop those out, one of the just something general in the software, when you zoom into an area of the DTM or DSM, and you want to change the color spectrum so that you can see things better, we have a tool up in the upper right corner that allows you to do that.
Are you talking about the shade DM variations? Mm-hmm. And then because you have like as you said, you have different ways of displaying the DEM. So you can use the grayscale. So let me put back the shadows here, the shaded relief. So yeah, as you mentioned, I always like put my view when I'm editing or playing with DM. I always use the shaded relief option, and then sometimes I switch from the color to the grayscale, depending on the topographical variations. Yeah. But yeah, this is and the stretch here, the stretch display to visible area. That's a good one, because if you work at the full extent here. Sometimes you want to refresh the stretch of and then the stretch is basically based on the color ramp you see on the side of the screen. Yes. So from 0, and you see here I have a minus 3.1. How come can I have negative values? Maybe there's a pixel somewhere, a negative spike over my project that has a negative value, a good way to select this is by simply drawing a polygon around. Because as I mentioned, you can snap to an elevation above a given value, but you can also snap below. So if I try to like snap the pixels that are below elevation 0, and you click on process, you see here, it might be complex, but you see here close to the water, I have like a few polygons that have been selected. And then these are my negative values. So I could set this to a given elevation, again using my set elevation here in the toolbar, or I could like delete and fill. You have a few options to fix these negative values you have in the river here. But going back to the stretch display to visible area, we basically use the color ramp you have on the side of the screen, and then if you zoom in a given area, it's supposed to like refresh by itself. So each time you zoom in and out, the stretch is supposed to refresh. But sometimes I manually go back here. I mean, click here on the stretch display to refresh my view and to be sure that I'm using the nice stretch values.
Yeah, I just think that, when you're in there editing, every once in a while you might have to adjust things so that you can see what you're editing a little bit better, and that's a nice tool to use. But you just brought up the negative values, and where I see that a lot is with drone flights, especially when maybe they're not flying. Maybe the edge of the project is over forest or something like that. So, when the software is building the DSM, it doesn't really have a lot to hold it together on the edge. So you start to see spikes and things like that. One thing you can use is that tool to eliminate those spikes. You can get the general elevation of the area, then find out everything that's below it and wipe it out.
Exactly. So most of the time, what I do on my side is I crop nicely the side of my DSM. So I have like a nice either rectangle, or you can do like a more complex polygon, but at least you don't have like curves or things like that on the side of the DSM. And then once this is done, I always go and check if I don't have like any negative, or like it could be like even positive spikes, topographical spikes. So I try to like clean up these spikes, and then you will see that if you have, let me draw here a small polygon, and then I'm going to put, not snap, sorry, I'm going to set this to negative, let's say negative 200. So if I do this here, you will see that the stretch of my display has changed a lot, because now the ramp is stretching from minus 200 meters to 156 meters. So when you see that you have like a very homogeneous stretch, color stretch like this, you know that you have a few pixels, like a few spikes somewhere. And when you do this rectangular selection over your I don't know, UAV project, and then you try to like snap to any pixel that are below 0, you will select these pixels that are causing the issues, and then you can click on the delete and fill, for instance, and you will see that the stretch will be fixed automatically, and you will now see like a nice the ramp of color over the DSM.
So that brings me to another thing that we see quite a bit now. Now that we have the ability to import LAS files, again,
yes.
Correlator 3D is, it's not a point cloud tool, it is a raster tool. So when we bring in a surface, even if it's a point cloud, the first thing we do is we convert it to a raster. We also produce an intensity image out of that. But a lot of times when we bring in a point cloud, the point cloud may not be clean. Or it may be that, for example, here in the US, when data is provided to say USGS, they want all the points regardless if they've been classified or not. So you have bird strikes, you have things like that.
Yes.
And those, when we import that point cloud, come into the raster as spikes. So the tools we're talking about here can be used if you don't have the ability to clean the point cloud on the way in before you use it. You will have those spikes, but you do have the ability to use these tools to eliminate those spikes when you're creating your surfaces.
Exactly. Very helpful when you especially the fact that you can snap to a below or above a given elevation, so you can remove negative or positive spikes, which as you mentioned, it really helps when you have like let's say uncleaned or like sometimes you denoise, you remove the noise from the point cloud. When this is not done, you just have like the raw last file. Then you can do this cleanup within the software. So.
Yeah. And again, the other thing you mentioned was when you're cropping the DEM here to what you want to work with. A lot of times I see people working along roadways, along corridors, where they've got a blocked flight or they've got a large flight that goes beyond the boundaries of what they need, which is good. You always want that. But once you get into the software and you start working with it, if you've got a shape file of your project boundary, feel free to bring it in and crop that surface based on that shapefile. It will eliminate a lot of headache with editing if you don't need to use those areas.
Yeah, and this is something I always do when I first start to work on a project. I always go online. So let's say I'm working in British Columbia here. So I go online and then I check, do I have access to any open source or public data of the roads, of the rivers, of the lakes. And then when you have like a few lakes in the region and you can get like these files online, then you just like bring them in and then you use them to remove the noise or to clean up the DSM. So.
Okay, well, I mean we've covered everything we've talked about. We're getting a ton of questions, and honestly, they're a little bit complex. So any questions that if anybody has brought up, we've got them to the right of us, and we're going to answer those. What we'll do is we'll answer those individually offline. We'll get them back to you. So we went over again DEM editing tools and processes, creating better surfaces with these tools, workflows for infrastructures such as buildings, bridges, elevated roadways. We talked about eliminating anomalies in the surface. We talked about how we could bring in shape files to fix those, for example, hold the water values, things like that, water elevation values. Some of the tools that we have for inspecting surfaces, always visualization. You always want to check it visually and make sure everything's good. Thomas mentioned, again, go out and look for existing data sets, roadways, water bodies, things like that. Depending on where you're at, what country you're in, a lot of this stuff is available. Bring it in, look at it, whether you're working in Esri or QGIS or whatever. We also went over options for creating the orthos, what might be the better way to do it in mosaic generation. And I guess the one thing I would add to that is, as you start getting into bigger projects, 3,000, 4,000 images with a drone, or 500 images with a large format system, work on a small area. Test what you're trying to do, because it'll take a lot less time. Once you've then developed the routine that you want to use, that it gives you the output that you want, then run it on the whole project. It'll save you a lot of time, minimize the headaches. So again, we've got your questions. Keep sending them our way. Thomas and/or I will get back to you in a timely manner with those. I'd like to thank you for attending. We appreciate your time, and we hope these are of value. If you did like the webinar, if you would like to know more, go to the website and fill out one of the questionnaires. One of our folks will be happy to get back to you. In the software, we have the user manual. The user manual is also online. We have plenty of tutorials and a knowledge base that we keep up to date. So thank you, and we'll talk again.